Welcome to another episode at Economics Design. Remember, the theme for this month is NFTs, non-fungible tokens. I'm sure you've heard that the art by Beeple sold for $69 million, of which $60 million is the art itself. So the whole point is that NFT is booming and transaction fees is a problem. So today I want to talk about Polygon for NFT. So Polygon is one of these underlying architecture that's supporting all these different NFT creations. And I thought this is a lot more interesting if I can share a little bit more about the economics of how all these different NFTs work and what is the underlying infrastructure supporting that. So today we're going to talk about the economics of Polygon. Before we get started, I just want to remind you that Economics Design is open for donations on the Gitcoin grant, and the round 9 is open, so we are available over there. If you have some spare change, please consider donating because your donation will help us to increase the video production. As you can see, I've upgraded the mic, I've upgraded the background, so hopefully, slowly, step by step, the video production quality will increase and can increase, so I can focus a lot more on video content, and more people will be excited to be learning about what all these different NFTs or tokenization, economics, and DeFi is all about. So if you want to donate, just go to bit.ly/ed-grunt. That's bit.ly/ed-grunt, and it will bring you to the Gitcoin page. Okay, so donations aside, let's get started with the value that you are here for. Again, it's always a disclaimer, this is not investment advice. Please do your own research. This is purely educational. Today we're going to cover Polygon. So we're going to cover what Polygon is, how Polygon works, as well as the interaction between Polygon and NFTs. After all, this month is all about NFTs. So what is Polygon? The token is actually Matic, M-A-T-I-C. Polygon used to be Matic. About 2-3 years ago, there's 3 groups of developers. They had this idea of creating a layer 2 just for Ethereum layer, and they call it Matic. They've been working for some time, and today it's live. And they changed it also now to Polygon. So layer 2 is just layer 1 is the base layer. So layer 1 could be things like Bitcoin, Ethereum, Polkadot, Luna, and Binance Smart Chain. So these are all layer 1s. These are the core underlying fundamental layer to allow all these different transactions to work. So these are basically big databases. All these transactions that's going on, they go into this big database. That's layer 1. Layer 2 is this smaller database that exists on top of this database for faster and cheaper transactions. As you know, the transactions on layer 1 are very, very expensive. A lot of these transactions on layer 1, they are more expensive, but also because it's more secure. So if there's going to be a lot more art going around, there's a lot more NFTs being created, we don't want to be paying so much money all the time. What can we do? This is where layer 2 comes in, because layer 2 is where we have faster and cheaper transactions. And this is the perfect use case for NFTs. And that's why I want to talk about it today. So how does Polygon work? Polygon works in 4 composable layers. The first layer is the Ethereum layer. The second layer is the security layer. The third layer is the Polygon network layer. And the last layer is the execution layer. So we're going to go into these different layers one by one to understand them a little bit more. So the first layer, the Ethereum layer, I call this the OG layer. So the original layer, that's layer 1. And this is where the core basic, fundamental architecture of all these different transactions will be recorded there. That's like a huge database, and it's the core database. This is where finality happens, staking, disputes, messaging, all these different crypto-related verification, that's where it all happens. It happens in that Ethereum layer. So that's very secure, but because it's also so secure, you sometimes have to trade off in terms of scalability. So that's our Ethereum layer, the OG core layer. Then we have the second layer, which is the security layer. So this security layer is they just exist above the Ethereum layer, and what it does is it runs parallel to the Ethereum layer. So it's kind of like a synthetic world or the Sims world. The Sims world where you exist in real life, and in your Sims computer game, you have this person that's living a similar life with you in a different kind of house. So it's the same idea where you have all these transactions that's happening on Ethereum layer, also on the security layer. They run parallel with each other. So you can share the different kind of validation or stakers, validators in the Ethereum layer in this security layer. I don't want to give you too much details of all these different technical stuff. There are a lot of other information you can learn elsewhere, but today we want to focus more on how this affects NFT, so I'm just going to give you a quick overview. Thirdly, we're going to move on to the Polygon network layer, which is something that's super interesting because this is where Polygon comes into a little bit more of a... That's where Polygon comes in. So this Polygon network layer, we look at transaction collateral, we look at consensus, ordering, data. This is basically where the layer 2 exists. And this is where you can have your own consensus in your different kind of applications. So what do I mean by this? Let's say I'm going to create a Lisa token and a Lisa network. On Ethereum, they use proof of work right now and they're changing to proof of stake. But I don't want to use any of that because in my Lisa ecosystem, I want to use delegated proof of stake instead, which is a different consensus mechanism. Now, on the Ethereum layer, I like a lot of things that the Ethereum layer does, but this consensus mechanism that Ethereum layer has is not related to what I want. So what I can do, I can still tap into the Ethereum layer because all of this is based on Ethereum layer, but I create my own sub-blockchain ecosystem using the Polygon network to create my own consensus, to create my own structuring of economics. So that is what I can do on the Polygon network layer. And this is where, remember I told you like ZK rollups, optimistic rollups, sharding, and all these different types of layer 2 scaling solutions can all be added in this layer. So what it means that Polygon network layer allows you to create your own logic for your own blockchain, and it's a lot faster and it's a lot cheaper. And then you have the execution layer. So the Polygon network layer where I create my own logic, I create my own consensus. This is the basic understanding of how these data will flow. But the real core of all these the real value add is in the execution because I can code a lot of different economics logic into smart contracts and then they can be executed. So this is where the execution layer comes in, where you can build different smart contracts or you can build different execution environment to execute your ideas. So, and that's basically the smart contract application layer. And if I can just summarize them a little bit better, security layer and Ethereum layer, the two base layer, they are for, they're for different kind of projects. Projects that requires a lot more security in management, security in finance, and you're willing to pay a lot more in transaction fees to get it started and going. If I'm, let's say, a video game company, or if I'm building a community-based ecosystem, or I'm building NFTs, I don't want people to be paying so much in transaction fees. I'm okay to offset a little in security, but increase the transaction speed or reduce the transaction cost. And at the same time, I want to build my own governance or my own logic and my own understanding and build my own smart contract upon that governance and logic. That's where I go to the Polygon network layer as well as the execution layer. So I hope that makes a little bit more sense. The Polygon network layer is a layer on its own. The execution layer is a layer on its own. You can just choose one of these layers or you can choose all of these layers. It really depends on your use case and how you want to play around with all these different smart contract logic or these different economics that you're building. So that is the basic understanding of Polygon. So what we've talked about so far is understanding Polygon and how Polygon works as the architecture. And now I want to take it back to context of NFTs and how NFTs and Polygon work together to add a lot of value to the NFT ecosystem. So what's the problem with NFTs? There are two main problems. They all boil down to the same core problem, is that transaction fees are so expensive. And you look at transaction fees in two ways. The first one is when you're minting. The second one is when you're paying and transacting or trading. So when you're minting, you have to pay a lot in transaction fees as a minter, as an artist. When I create my art and I put it on the market for sale, I have to create it. The creation process is very expensive because to create it, you need to pay transaction fees. That's not cheap. Then the second thing is when I want to buy from an artist, I'm willing to pay the artist for sure, but I'm also paying a lot in transaction fees to buy that art. And that, you could argue that that's one of the reasons why all these NFTs are so expensive, because the transaction fees itself is added into the cost of this entire, the cost of minting is added into the cost of the NFT itself. So there's an inflation in price because of that. And this is not really fair because some NFTs are really beautiful and we want more people to have access to it. The idea of crypto, the idea of blockchain, the idea of DeFi, or decentralizing all these things is to make things accessible to people. But having this barrier to entry where it's so expensive to even get started with buying one small art piece is difficult to buy, then it's not exactly what the philosophy of Bitcoin or blockchain or decentralized ecosystems is about. So that's why the solution is to make minting cheaper. We want to make two things. We can make transactions expensive. That's fine, that's a whole argument on its own. But the core argument is that we want to make minting cheaper because minting is part of the cost price of the artist to be creating these art pieces. So if you reduce the minting cost or if you reduce the minting fees, then the cost price to create or to produce these art pieces will be less, and hence the art pieces will be slightly cheaper and more accessible for people to buy. So that is the idea. And if we go back to think about, okay, so we need to make things cheaper, we also understand that the Ethereum layer is all about security. We talked about it just now with the 4 different layers. The Ethereum layer and the security layer is kind of expensive and it takes time to validate. It's actually quite expensive because security, it's all about security and it's all about finality and validation. What if we can do something on top of this secure stuff, but allow things to be a bit cheaper? Can we do that? Yes, we can. So if you look at what Polygon is doing, Polygon is really powering the NFT space and the NFT ecosystem on the Ethereum blockchain. So Avegochi chose Polygon. Polygon is working with Atari in its NFT bet. So Atari is this huge gaming company. They have a lot of virtual games, virtual goods, digital assets. And imagine all these digital assets that you have on computer games now on NFTs, because it's not a big difference. You still have your digital games, just that when the computer servers shut down, you still have your special sword and special armor and special skins. So NFTs in computer games is not a big shift from the existing model that you have. It's just a lot more benefits. So Polygon is partnering with Atari to be building this digital assets that you can own forever. Then Superfarm also partners with Polygon for NFT farming. There's also Metaverse that is an NFT marketplace that's built on Polygon. And then there's also, Polygon partnering with other NFT, with Bounty Block of other NFT related things. So NFT itself is very interesting. Okay, I'm very fascinated with NFTs. In fact, as you know, I'm playing around with experimenting with NFTs on my distribution and publishing rights of the book, because right now we're just at the peak of what NFTs could do. Right now we're looking at how NFT can be tokenizing art, digital goods. My future is where NFTs can be tokenizing legal contracts. So I'm experimenting with distribution rights, publishing rights, different kind of franchising, different kind of intellectual properties, copyrights. Well, I'm experimenting with that. And the key thing is that before we go into all these complicated things, we have to make sure that we have the right infrastructure in place to allow people who are not comfortable with high transaction fees or not comfortable with the crypto space to ease them into understanding, actually, it's pretty much the same thing as what I'm used to before, just that I have a lot of other benefits, and I don't have to pay a crazy amount of fees. And this is where Polygon comes in, because the Polygon network layer, the layer 2 application, and the smart contract layer, the execution layer, it allows all these different NFT assets to be built on this Polygon layer with the underlying infrastructure of the Ethereum security to allow for faster and cheaper transactions. So that's why it's super interesting and super fun. So when we talk about mechanism and feasibility, let's take a look a little bit more about what the Polygon network itself is doing. So how I see Polygon is that it is the infrastructure layer of NFTs. It is the infrastructure that's powering all these different NFTs to create and exist. NFTs are very expensive. NFTs are currently being created on the Ethereum layer, and they're getting more and more expensive. More and more people are interested to come into the space, but they're hindered by the expensive transaction fees. By having a core layer 2, which is Polygon, to focus on building and minting this infrastructure layer for NFTs, that's actually very, very interesting and very fun, because you have this core specialization of infrastructure that focuses on these NFT ecosystems. And why is it beneficial? Because one of the beautiful things about these token ecosystems is that it allows for network effects to really flourish exponentially. So once NFTs get to communicate with each other, you have ease of transacting your tokens to another person's tokens in different kind of ecosystem. It's almost like interoperability, but the base layer is all the same. It's all built within the Polygon network. Then that just compounds the value that they can bring from one ecosystem to the other. And that is actually super interesting, super fun, because I don't know how NFTs will go. I don't know if it's going to be Aavegotchi that will soar very high, or is it Atari, or is it Super Farms, or the Metaverse, or the Bounty Block. There's so many NFTs out there, and they're all competing in different ways. So that's fun, that's good. But I'm very bullish in NFT as I mentioned. I think NFT is huge because there are a lot of other things that we can embed into these tokens. But I don't really know which kind of NFTs will succeed. But if there is an infrastructure layer that is supporting these NFTs, that allow these NFTs to speak to each other, that allows this customization of ecosystems as well as communication between these different NFT ecosystems, that's actually super interesting, and that's actually a very important infrastructure to have as we continuously grow this ecosystem. So when we look at understanding the tokens involved in NFTs, I want to focus a little bit more on token design. So remember, in the token economics, or the economics design framework, we have market design, mechanism design, and token design. In the market design, as I mentioned, there are a lot of different partners that's already building and working on NFTs on the Polygon network, and it's already live. There are also a lot more, there's a lot of transactions going on. There is, I think, 5 million over transactions that is done. There's a lot, I think $200 million worth of people's transactions. So 5 million transactions value, the number, and 200 million in notional value being transferred in the Polygon network, and it's growing tremendously. So market design is pretty robust. The mechanism design is more of the governance structure, the consensus mechanisms, the different ways of creating the layer 3 Polygon network layer. So that's also highly customizable. They're experimenting and building in a lot more different layer 2 mechanisms. So that's also quite robust on its own. And you can find those things online. So I want to dive a little bit deeper into the token design, especially the supply of the tokens available. So right now, the project started about 2.5-3 years ago, and right now there's 70% of the tokens in circulation. The inflation rate is about 14.2% by the end of this year, and the full circulating supply will end in 2022. So a lot of these rewards will be given to these validators and stakers, and also and these token holders also get different rewards from transactions by being a validator. So in that situation, it becomes a very interesting way of understanding the token, because what we've seen so far in a few of the other tokens, especially in DeFi tokens, right, in finance, these tokens represent some form of structured products. So in options, we have tokens being structured products, and you can buy these tokens to get exposure to some underlying assets, and in some very funky ways. So that's super fun and interesting. On the other hand, with NFTs, you have tokens that represent the assets itself, and then you have these tokens in the infrastructure layer where it's validating these different transactions. So looking at the inflation rate of 14.2% is actually quite high, but at the same time, having so many people, so many different kind of projects and protocols being built on the Polygon layer, especially all these NFT protocols being built on the Polygon layer, you will need more validators and you have more transactions going on. And this ties in very nicely, so that high demand ties in very nicely with the inflation supply or inflation rate of 14.2%. So I thought that was very interesting and I wanted to share that with you. Because this is not investment advice, absolutely not investment advice, this is also not financial advice, so I hope you get to read between the lines. Lastly, before I end, I just want to share that I've written a book, the Token Economics book. The link is over here. You can feel free to check it out. A lot of people are reading it, and a lot of people really like it very much. So thank you you guys for reading it, and I'm glad that the book is helping you to understand the space a little bit more. I'm very excited to see more and more people from traditional finance coming into the DeFi space, because we definitely need more brainy people like you guys. And together we can really make this a big difference. We can really turn this DeFi world, this crypto world, tokenization world, into something that will make the future a little bit better. And that's all that matters. Till then, I'll see you next week. Bye!